Hello guys, hello everyone. Today in this class we finish in previous call we finish dimensions, limitations of dimension and some problems on dimension. So in this class, one minute. In this class we will study rounding of number. Yesterday we studied significant numbers also. Significant numbers, how many significant numbers are there? Significant numbers means the number up to which we are confident of. Now in this class, we are going to study rounding of number. If you have a number like 1.333 something, that kind of number, how we will round? How we will round? So see, rounding of number, which means I will give you example. For suppose this kind of number, you will simply write it as let's say here one more six. You will write it as 3. Why? Why this 6 become here 3? This kind of things happening now. Now we are going to study that only. That only. And how, what is the process we are going to study. So there are 5 rules to rounding up any number. See, if the digit to be dropped is less than, to be dropped is less than 5, the preceding digit in the left unchanged. It means very simple. If I take number for suppose 7.82, if the digit to be dropped is less than 5, see this one, if it is less than 5, sorry, less than 5, then this digit we will leave as it is, no changes. If this is greater than 5, then we will check, we will discuss that also. See, when we have case 3.94, in this also, see this one, this is less than 5, which means this is not gonna change, this is not gonna change. Rounding up number, if this number, any number is less than 5, beside of this number the previous number left unchanged, no changes in that number. Similarly, if the digit to be dropped is greater than 5, then the preceding digits rise by 1. Rise by 1. Now what it is saying? It is saying like for suppose if we have this number. Now see this one. This number is greater than 5, greater than 5, greater than 5. If this is the case, greater than 5, that time the number beside it, it will rise by 1. It will rise by, now I will take this one example, see, 9.36. Now this number is greater than 5, which means this previous number is increased by 1, is increased by 1. 3.5, it's become 4.0. Or you can even say 7.88. See, this number is greater than 5, which means this previous number increase one number. So simple. Now let us see third property. How is third property? Two property is clear. One, if a number is greater than 5, previous number rises by 1. If number is less than 5, previous number remains unchanged. Now see, what if we have number 5 only? See, if suppose only 5. At this time what we have to do? We will discuss one. See, if the digit to be dropped 5 followed by digit other than 0, which means after this 5, here the digit which must not be 0, then the preceding digit rises by 1, then this one rise by 1. What they were telling, very simple. Now take one case, this is, you have number. Now it is 5. If it is greater than 5, you will increase this by 1. If it is less than 5, you will remove it as same to same. But it is exactly 5. At this condition, you have to see the number next to this number. This number, if it is non-zero, if it is non-zero, which means any number, any like 2, let's say 2. At this kind of condition, you will make it as 1 increase. It become 9. It's become 9. Clear up, clear up. See, I will take one more example. 16.351. Now here exactly 5. If greater than 5, we will write increase 1. If less than 5, we will keep it as same. But here exactly 5. At this time, you will see this number. If it is exactly 0, then you will keep same percent. But it is greater than 0. one number. At that time, you will increase this by one. Understood? Huh? Three rules, crystal clear. Three rules, crystal clear. Three rules. Now, last one. If the digit is dropped to be five, or is five, or five followed by zero, then the preceding digit is raised by one. If it is odd, if it is odd. See, first, first let me take one example. Let me take one example. Before this, I will take here six. Now, this kind of thing, this is 6 greater than 5, you will write like this. Now, if it is like this, it is less than 5, you will write it as same. Now, if it is 2, 5, let's say 3, this number after this number is greater than 1, sorry, greater than 0, that 10, you will write this greater than 0, which tree point increase by 1. Now, what if you have exactly 0? 0, this condition at this time array, where is the array? One second now. What happened, bro? Okay, at this time what you will do now, you will see the number beside this 5, beside this 5, beside this 5. If this number beside this 5 is odd, odd, only odd, then you will raise this one number. If it is even, you will keep it as same. If it is odd, say 350. Now 5, after 5 exactly 0. If in the place of 5 is there is 1, then you will write like this. But here it is exactly 0, exactly 0. After 5 it is exactly 0. At that time you will see one number here. It is even or odd, it is odd number. So it is odd number, which means we have to rise by 1. This is at your significant, sorry, rounding up. Rounding up number, only 4 cases, only 4 cases, only 4 cases. One, if any number is less than 5, then this remains same, unchanged. If any number is greater than 5, then you will change this to rise to one number. Now, similarly, third case, if number is exactly 5, if number is exactly 5, that time you will see the number next to 5. If it is greater than 0, let's say 1 or 2, anything which is not 0, at this time you will rise. Now, the case, if number is exactly 0, at this time you will see one number beside of 5. If it is odd, if it is odd, you will add 1. If it is even, you will remain same. It will remain same. Simple case. Now, rounding of figure is clearer. I think so. Rounding of figure clearer. Rounding of figure clearer, boys, girls.
Yes, sir.
Yeah, super. One small thing. Now let us study errors, which is very important, very important. Errors. Now the name itself is telling error. What do you mean by error? Before discussing error, let me tell you one thing. However we do experiment, we are doing an experiment, we will never get a perfect value. We will never get a perfect value. There is always some variation in our value and true value. That our value, that difference is there now. Is there, say, some say you done an experiment, the real value is 10, you got some value 9.7, the difference 0.3 is there now. That is called your error. That is called your error. See, in spite of our best efforts, the measured value of a quantity is always somewhat different from its actual value or true value. Which means what, however hardly we try, and measure a value, there is always some difference between original value and measured value. That difference is called error. See, this difference in the true value of quantity is called error. For suppose, let's say you are calculating velocity. The real velocity is 10 meter per second. You are trying very hard doing one experiment which has a distance by time. always you are getting answers like 9.8, 9.7, 9.9. You are not getting exactly 10, you are not getting. There is always some difference. Or else you are getting like 9.1, 10.3. You are not getting exactly this. The difference between these two is there now. That is called your error. Error. Now in error also there are few types of error. Before you discuss few types of error, I will tell you one thing. In the universe, any experiment, no experiment has a true value. Now you will say now the focal length of our eye is 15 centimeter or whatever. For example, no experiment in the world has true value. Remember this. No experiment in the world has true value. Sir, if no experiment has true value, then how we calculate, how we know something is true value? How? It is very simple. True value, it is like you are doing experiment n number of time, n number, many number. If for suppose you are doing experiment, let's say 10 times, 1 plus 1 plus 1 plus 1 plus 1 plus n number of time, n number of time, n number of time, doing one simple experiment again and again and again and again, you will get values different values, and dividing by how many number, how many number, at that time you will get some value now, some value. That is your true value, that is your true value. Always remember, in the world, there is no true value or absolute value. Absolute value is calculated by repeating experiment n number of time and dividing it by number. That's it. So if someone say, is there any true value? Say them, no. In this world, there is no true value. Not even of your star distance, moon distance, your height. Nothing is true value. Just measuring n number of time and dividing it by n. Okay now. Now let us see. In errors, there are few types of error: absolute error, mean absolute error, and there are one more error. We'll discuss. What is that error? Absolute error. It is a difference between measured value and the true value. So simple, so simple. Now just now I said how you will get your true value, true value, true value. You will get by repeating n number of time. You will get one experiment repeating by n number of time. Let's say at first experiment we are done, and second, similarly we are done up to one experiment n number of time, dividing by n. We got our true value of this a. We are doing some experiment which is named a, which is named a, and we don't know true value of a, true value of a. So what we'll do, we'll repeat this experiment a n number of time and divide it by n number. So whatever the value comes, it is your true value, true value, true value. Now you just got your true value, true value. Now absolute error means the difference between measured value and true value. Now you just got true value. Measured value you will get by measuring, doing one experiment one time. You will get measured value. Say measured value. Let's say measured value. Your measured value is equals to m. A. This is your measured value, measured value, and this is your true value. True value you will get by repeating n number of time. Measured value you will just measure one time, you are measuring one time, you are doing experiment. The difference between these two is called your absolute error. The difference between these two is called your absolute error. It is like absolute error, it is like, sorry, one thing, absolute error a is equals to the difference plus or minus of. Just simple. Sir, you said difference, but you are writing plus or minus. Plus or minus. Plus or minus. Why? Why? I will tell you. I will tell you. If you are doing an experiment, there are two maybe chances. One, the value must be greater. The result of your value may be greater or maybe lesser. If it is greater, that time this happens. If it is lesser, that time this happens. It says it is the minimum error you will get in your experiment, and it is the maximum error you will get in your experiment. This is your absolute error. I think it's clear. If it is not, you can ask me. I will once again explain it. It is clear?
Yes, sir.
Okay. Now, mean absolute error. What do you mean by mean absolute error? The name itself telling. Just now we discussed absolute error, and here it is telling mean, which mean of absolute error. See, it is arithmetical mean of magnitude of absolute error in all the measurement of quantities. So simple, so simple. It is mean of your absolute error. Mean of our absolute error. It is like we represent mean absolute error by this. Now just we got our values. Once again, this we represent like this. Wait. Very small thing, guys. There is one small thing in this. I forgot one more thing. Nothing is complicated, everything is easy. Just one small thing. Now, for this you will represent by this, not this one. And it is a difference between measured value and true value, right? Measured value, I will take one example. For experiment A, the measured value is AM minus true value, whatever the true value, let's say this one. Now, for A2 also, measured value and true value, measured value. Fine, fine. That's it. Array. Now, mean absolute error. It is a mean of this one. It is a mean of this one. It is a mean of this one. You are doing one experiment n number of time and making it mean. That's it. Mean of that experiment. It's called mean absolute error. Mean absolute error. The name itself telling mean of absolute error. Clear? This also same. It is up to maximum and minimum. It is also up to maximum and minimum. Mean absolute. It is also up to maximum and minimum. Similar. Now let us say relative error or fractional error. See the name, fractional error, which means errors in fraction. Relative error or fractional error. It is so simple, right? Relative error or fractional error, it's given by mean absolute error divided by mean value. Just now we discussed mean absolute error divided by, you know how to get your mean value. Repeating n number of time, you will get your mean value. This is your mean absolute error or fractional error, which means this value you will get by mean absolute that I said now. Adding all this, dividing by n, you will get your mean value. And if you divide this mean absolute error by true value, you will get your relative error or fractional error. Okay, now one more thing, percentage error is very simple. It is percentage of fractional error or relative error. Percentage of relative error or percentage of fractional error. So how, just now we got how to write percentage in fractional error into 100. That's it. That's it. That's it. That's it. So simple. Now we have four errors. One absolute error, one mean absolute error, second one relative error or fractional error, and third one percentage error. Four are very simple. Simple. Now let us see. It is clear. That's it about errors. Now we will see sum of errors. Guys, errors okay. Four types of error. Four types of error. Simple concept. So I'm going first. Four types of error. Okay. Only one girl will respond now. Yes, sir.
Okay.
Yeah, I was going. Okay. Now let us see. Just now you learned all the errors. Let us see the addition, subtraction of the errors. errors in sum and difference. How this? See, errors in sum. I will take x is equal to a of plus or minus b. Plus or minus b. This is normal numbers. Normal number. I will add it as I will add them error. I will add them error. How will I add? See, x plus or minus. I will add error. This is your error is equals to same for I will do same for your a also plus or minus same for b also b plus or minus adding error. Okay, now what I will do, I will write your first term as it is. Now in this I will remove a plus or minus of a divided by a. Yeah, once again 1 minute. What's happening here? What's happening here? Wait. Okay, now I understand. Now I will write it as like this plus or minus b plus or minus b. Sorry, this one is b. This one is b. Error of b, right? Now can I write this as like this? Is equals to a plus or minus b plus or minus a plus or minus b. Now if you closely see, this is equal to yes, this is equal to x. Now this x get cancelled. Now in addition error become plus or minus of this is your error. Hey, என்னடா இது? This one is x, right? Aiyaya, no one told me. This is error of x. Sorry, man. This is error of x. Just simple. This was addition and subtraction. Addition subtraction. This is general formula. X is equal to a plus rb. Now for that I have added error. For x I have added error. For a I have added error. For b I have added error. Now I have separated this a and this b, which is cancelled by this x. Now final I will get this expression, which shows error in x is equal to error in b, which means whatever error of x, it is a sum or difference of error of a and clear. Super, super clear. Now there are this you can write like there are four cases exist. See, one plus or minus. Okay, let me take only plus only plus or minus a plus, just this is there now. For this I am writing in simple form simple. These four formulas I will get from this. You don't need to remember all this, just this is enough, fine. Super. Now let us see what let us see. We see nothing. Where it is gone. Okay, here it is. Now addition of vector is over, addition of errors are over. Now similarly let us say multiplication also. Addition you got to know, whenever you see two vector how you will add, you got to know. Now let us see whenever you see two multiplications of errors, how will you multiply that error. Let us take x is equals to ab. Simple again. I will add here errors. X is equal to plus or minus x. Error added is equals to a plus or minus of error added, error into b plus or minus of error added. added. Now what I will do, I will remove common. If I remove a common from this, it will be error a divided by a, and if I remove b common plus 1 or b, error b divided by b. Now here AB multiplication, here it will be AB, which is equal to x. So this x get cancelled by this x, right? Right. So finally I will get delta B is equals to error x. Oof, oh. error x error x is equals to 1 plus or minus error a divided by a error a divided by a and 1 plus or minus error b divided by b. Now if we cross multiply this one, what remains, first one multiply one simple, and this will come plus or minus. If I multiply this to here, it will be a by a. Multiply this to here, it will be plus or minus error a by a, error b by b. So simple case. Now one more thing. In this also I will remove x outside. In this also I will remove x outside. If I remove x outside, it will be 1 plus or minus error by error. Now cancel your x. Here there will be 1 plus or minus. 1 plus or minus. This one get cancelled. And this value is there now. This value is very small. Very small. See, two vectors. Normally we have two fraction vectors here. So fraction vectors. Two fraction. It is fraction only, right? Mean divided by true value. Fraction only. Fraction only. It is fraction vector. When you multiply two fraction, for suppose here let's say this one fraction divided by multiply by this fraction, your value will become like 0.005. It is very small. So you can say this is very small. So we are ignoring it. It is very small. We are ignoring it. We are ignoring it. So finally we will get our answer, right? Error is equals to error in B divided by B plus or minus error in A divided by A. This is your error in multiplication. This is your error in multiplication. Now in these, if you have only positive sign, it is maximum error. Maximum error. If you have negative sign, it is minimum error. Minimum error. It is like there is one value 10. 10, you got some value in let's say your error is 0.2 plus or minus 0.2 your error. Now what will the maximum error 10 plus 0.2, your minimum error 10 minus 0.2, this will be 10.2 or 9.8, which means minimum is this error, maximum is this error. In that experiment, hardly minimally this can error exist or this can exist. That's it. Below this, above this, no chance. This is your multiplication of error. Similarly, let us see division also. Last case, division. Shit. Division of errors, which means x is equal to a divided by b. Similar, I will add here our error, plus or minus error. For above also I will add error. How can I add error? A. Add, try this one. A plus or minus square root of a, this one x, divided by b plus or minus error of b. Now if I remove a common, it will be like error of a divided by a, and similarly down, error of b divided by b. Now in this I will remove x common. It's become 1 plus or minus x divided by x is equals to a by b, and your formula. Now this a by b is equals to x, which this one get cancelled. Now we remain by 1 plus or minus x is equals to, this one is x, is equals to 1 plus or minus a by a and 1 plus or minus error b by b come this one, this one, this one. Now, and one more thing here, see, this is much less than 1, much less than 1. This one is less than 1, so we'll ignore this already less than 1. For less than 1, if you again divide by something, it will become very low value. So we will ignore here negative sign. We will ignore here negative sign. Now what remains? This one is your remaining. remaining. Now again same multiply, cross, sorry, multiply. You will get your answer like if you multiply, keep on multiplying. 1 here plus or minus x is equals to 1 plus or minus square root error b by b plus or minus error a by a plus or minus error a by a error b by b. Again this one becomes equals to, this one becomes negligible because very small error, and here your one get cancelled. Now totally your error comes in division also. Your error is plus or minus b by b plus or minus a by a by a. This is same error in your addition, sorry, in your multiplication and your division. In both errors are same. That's it. Now there is one more small case, one more small case. This is division and multiplication, man. Division also over, multiplication over. Now let us seriously discuss one last case, which is what if you have powers like x to the power of a to the power of n, b to the power of m. Like this type, how will you calculate errors? How will you calculate errors? Such just simple. You will just add lan both side, lan both side. Let's say lan of x is equals to, you will write this, like this. Lan of x is equals to, let's say lan of a to the power of n divided by lan of b to the power of n. For this kind, this will become like lan of x is equals to n. This n comes downside, n lan of a minus, this will go upside and become minus m lan of b. Standard formula. Okay, now again your this one, error error is equals to n into error in a minus m into error in b, that's it. Now if you want to write this in a standard form, error x divided by x is equals to plus or minus n error a divided by a plus or minus m error b divided by b. That's it. That's so simple thing. When you have like this, you will use error. This simple things need simple solution. Just simple like x is equals to a to the power of n divided by a to the power of n. Whenever you see this, just add error first. Error is equals to, now it is a to the power of n. So you will add n first and error a divided by a plus m first, error b divided by b. Error b divided by b. Like for division case, just now you discussed which is positive plus or minus. For division case, we are just adding n in front. That's all. For division case, we are adding n in front. That's it. Your powers also. So, so thank you guys.